if I make it as dy by dx equal to, it will have a numerator and it will have a denominator. Then numerator and denominator both will be called what type of function they are? They will be homogeneous functions. Now, what do you mean by homogeneous function? If you replace x by lambda x, if you replace y by lambda y, a lambda raised to n will become common and you will come back to original function. And n is called what? N is called what? Degree of the function.
Degree of the function.
And you should have degree of the numerator and degree of the denominator should be equal. Then only it is called a homogeneous function. This is the definition of it. But however, by looking at it, it's difficult for you to think all this way. If it is a polynomial function, that means if you have only x square, x algebraic function, the degree of each term should be same. Degree of every term should have the same power. But sometimes what happens is, even if I put like this, x square into sine y by x plus y square upon 2x square minus y square, still it is a homogeneous function, because when I replace y by lambda y and lambda x, lambda will get cancelled here. So there will be no degree effect here. Degree effect will be only in this two. So still it will be a homogeneous function. If I had to put a e raised to y by x, still it would have been a homogeneous function, because when you put y as y is replaced by lambda y, x is replaced by lambda x, they get cancelled. So it's turned to be of the same degree. Is it clear to you? So let's have a look at next problem. Write down the question. Solve. So nobody will tell you it is homogeneous. You yourself has to recognize. 1 plus 2 e raised to x upon y plus 2 e raised to x upon y into 1 minus x upon y into dy by dx equal to 0. Now, since x upon y is the function here, so it is easy for us to put not y by x upon y as v. Suppose I had put y upon x as d, they will become 1 by v. Then this would become very difficult for me to integrate. So here, since the function is x upon y everywhere, and I will put x upon y as v. Now what happens is, x becomes a dependent variable, and y becomes x becomes the dependent variable, and y becomes the independent variable. So you will remove what? You will remove x and replace it by y, replaced by v. This is very important. So how will I write x? X equal to vy. So dx by dy I will take is v plus derivative of y is 1 plus y into derivative of v become dv by dy. Understood that? So I am removing which variable here? X. So that my integration will be much easier compared to what I was doing before. Let's try to do it. Now remember, this is dy by dx. So I need to modify this problem. It will become dx by dy. So how will I get dx by dy? I need to, okay, I'll do one thing. I'll show some more steps. Otherwise, you will have a confusion. So first of all, I will write this as 2 e raised to x upon y into 1 minus x upon y into dy by dx is minus 1 plus 2 e raised to xy. So dx by dy will be what? This will go to other side, this come to denominator. It will be minus 2 e raised to x upon y, 1 minus x upon y, divided by 1 plus 2 e raised to x upon y. Now I'll substitute this. Dx by dy became v plus y dv by dy is equal to minus 2 e raised to v, 1 minus v upon 1 plus 2 e raised to v. Now bring all v to one side. So y into dv by dy is minus 2 e raised to v into 1 minus v upon 1 plus 2 e raised to v minus v. Now let's take LCM and simplify this. Can you do it yourself now remaining?
Yes,
Just
sir.
try solving it. So took the LCM, y into dv by dy. When you open the bracket, this is plus and this is minus. So this and this will get cancelled. So minus 2 e raised to v minus v upon 1 plus 2 e raised to v. Y into dv by dy. If you take a minus common, 2 e raised to v plus v upon 1 plus 2 e raised to v. It's quite lengthy problem. So 1 plus 2 e raised to v upon v plus 2 e raised to v into dv is minus dy upon y. Denominator's derivative is numerator, so direct integration. So answer became log of v plus 2 e raised to v is minus log y plus log c. So we'll remove the log. Yes, somebody has given already the answer. Now we can remove the log. So v plus 2 e raised to v is c upon y. Now wherever v is there, you will replace by x by y. Now taking y as LCM, is the general solution. It's quite not very difficult problem, but you need to practice it, then only you can do this problem well.